Hi students, my name is Sumit Kundu and you are watching me live on the Unacademy JEE English channel. Alright, so students, today we are here for the session of Work, Power, Energy Part 2. We had our first part premiered on Saturday. Well, it was not premiere, rather it was a live session on Saturday. Well, yesterday was the discussion of the board's paper of your of 2020, right? So that's the reason why most of the students who had appeared for their CBSE examination, they were very busy trying to evaluate how did they actually perform. Some were relaxing, so we didn't go ahead with the live session yesterday. But here again we are live on this particular platform for the discussion of your Work, Power, Energy Part 2. I hope students you have enjoyed the first part and you're also going to love the second part as well. So guys, give me a good cheer if you are with me, and let's go ahead and all right, so there are a lot of students who are watching this live out here. Students, let me tell you, all the concepts that you would be learning in this particular channel, all the concepts that you will be learning in this particular channel right now in this particular session, they are very, very important from the JEE perspective. These questions have been picked up after a very, very deep analysis of last many years papers, and then we picked out or handpicked a number of questions, right? So that's the reason why I'll tell you that even you would spend hours of studying, and second thing, alternative is watch just 1 hour. That is going to create a difference. All right, see, there is no substitute for hard work, right? There's no substitute. I will not say, I'll never ever say that this is all you have to do, okay? But in your regular preparation, this forms a very, very essential part. All right, so you guys have been waiting for today's session. It's been a long time. Let me just introduce myself to the students who are watching me live for the first time. My name is Sumit Kundu and I am a BTech graduate from IIT Bombay. Okay, I had a rank of 2125 and it's been 10 years that I have been coaching, mentoring, teaching all students for physics for the different competitive examinations, not just your JEE mains and advanced, but also for NEET and other state level engineering examinations. Okay, because all I love is the subject, not the examination. Okay, examination is your priority, concepts is my priority. Fine students, let's move ahead. A few important things. tinyurl.com/JEE mobile. If you log on to this particular site, you will get the archive of all previous year's lectures, all the lectures that we have had in Unacademy. Okay, a similar thing is going to be there for the viewers who would want all their lectures in English now. Okay, because this was mostly in your Hindi. So if you're comfortable with Hindi, yes, you can go ahead, and you're comfortable with Hindi and English, you can go ahead and check out all of these. And the ones who are only comfortable in English, excuse me, who are only comfortable in English, this year onwards, you are going to have a similar platform or similar login, okay, which could probably be tinyurl.com/JEE English mobile. Okay, but that is yet to be launched. Okay, but very soon it is going to be there for you students exclusively. All right, now students, another very important thing, that is the code SMLIVE. If you are looking forward for a subscription, which is kind of so essential, all right, because you get to interact live with the educators here. So use this code and right away get a 10% discount. So you don't have to pay 32,400, rather you can just go ahead with 27,000. Now, next thing is we are coming back to the questions. So the wait is over right now. The wait is over. Good evening. Good evening, Himanshu. Good evening, Praveen. Good evening, Ravi. Good evening to all my students. So very important concepts that we are going to discuss in today's session. The first concept, without wasting any further time, the first concept that I am going to do with you is the concept of equilibrium. What is the concept of equilibrium? It's very simple. Okay, see, there are three types of equilibrium general theory points that I'm going to tell you. There are three kinds of equilibrium. We have stable equilibrium, you have unstable equilibrium, we have neutral equilibrium. Okay, stable is something that is, let's say you have, let me explain to you, very simple thing. Okay, stable is this. Stable is this. That is, this block which is lying out here on a pan, if I kind of take it to this point, okay, it is going to roll back to this point out here. At this point here, normal reaction is acting in the upward direction, mg is acting in the downward direction. They are balancing each other. Normal, mg, they are balancing each other. Equilibrium means what? The net force is equal to 0. What is it? The net force is equal to 0. So here the net force is 0. But why is it called stable? Because if I disturb the equilibrium position and I bring it here, it will keep rolling back to the equilibrium position. This is my stable. All right, this is called as my stable. Next comes is my unstable. Unstable is what? Unstable is this. All right, let's say I have an inverted spherical surface, and on top of that I have placed a block out there, right? Now here also normal is balanced by mg. Normal is balancing mg, right? It is in equilibrium, but now you just try to flick it with your finger, okay? Or let's say displace it a little bit. Yeah, don't flick it, I was just kidding, okay? So you just displace it a little bit. Will it come back to the equilibrium position? Will it come back to the equilibrium position? No, it is not going to come back to the equilibrium position. That means that this equilibrium is unstable. All right, so everybody understands the meaning of your stable and unstable equilibrium. All right, by the way, what we are going to do is we are going to look at the same scenario for charges. All right, and the type of questions which come in the examination, I'm going to explain that to you in a short while. Okay, so we'll get started off with this particular question here. Try and understand what is the meaning of your stable equilibrium and unstable equilibrium in case of these charges. All right, now all of you can look at it. I've got a positive charge here, I've got another positive charge here, and in between, all right, I have got a negative charge. All right, the first question I'm going to ask you is this minus q charge in equilibrium? You can give me your answers on the chat box. Come on guys, is this minus q charge in equilibrium? Yes. Why not? Because plus q will pull it with a force, let's say, equal to F, and this will pull it with a force equal to F. This F will be equal to this F, as a result of which the net force on this minus Q will be equal to 0, as a result of which it is in equilibrium. All right, now the first part of the question is actually done. Now coming to this point out here, state what is the type of equilibrium. State what is the type of equilibrium, whether it is stable, whether it is unstable, or is it neutral. Stable, unstable, or neutral. Okay, for that what do we do? Acha, state the type of equilibrium if the charge is moved now specifically along the x-axis. If it is moved along the x-axis, that means let me just take this charge and let me move it to this place here. Let me move it to this place. Okay, now here at the center, equal amount of force was acting on this charge, so net force was equal to 0. But when I moved it towards this charge out here, try and understand what is going to happen. This force F1 and let's say this force is F2. I can clearly see that my F1 will be greater than F2, right? My F1 will be greater than F2. Why my F1 will be greater than F2? Because it is going to be closer to this charge. That means it will keep on getting pulled towards this particular charge. Then will it come back to the position of equilibrium? It is not going to come back to the position of equilibrium. That means the type of equilibrium will be unstable if I move it along the x-axis. See, try and understand these concepts. All right, question will be automatically being taken care of. All right, questions you don't have to worry about it. Just understand what is the concept that I am trying to teach to you. These are the final moments of your preparation. So anyone who has left out these last concepts, okay, this bit of concept, all right, एक बार फिर से you can get it revised. All right, chalo, let's have a look at the next part of the same question. Okay, let us look at the next question out here. What do we have here? The type of equilibrium if the charge is moved along the y-axis. The type of equilibrium if the charge is moved along the y-axis. All right, what do we have here? Let's say this charge minus q, you move it along the y-axis. You bring it somewhere out here, right? Then what is going to happen? This is going to be exerting a force here. This is going to be exerting a force here. This force will have two components, one in this direction, one in this direction. Similarly, this force will have two components, one in this direction, one in this direction. What is going to happen because of this? This component is going to cancel this component. The net component is in the downward direction, so it is going to come back to this point here. That means if you are displacing it along the y-axis, the type of equilibrium is going to be stable. That is the central idea that we want to understand from this particular question. All right, chalo students, let's go ahead to the next part. Okay, now we have seen repeatedly that this is one type of question which has been repeated a couple of times in the JEE examinations. All right, what they do is they give you a function for force. They give you a function for force and then they give you graphs between potential energy and displacement, okay, and you need to find out as per this particular function of force which graph suits the best. All right, now for this kind of questions, there are just two things that you must know. Okay, what are those two things? Number one, you must know that force is minus du by dx, this particular relationship that we have. This is point number one. And second thing is analysis of graphs. All right, this is pretty well acquainted that you would definitely know. All right, by the end of your 12th standard, you must have encountered this multiple number of times. That is, when a body is in equilibrium, that means net force is equal to 0. If net force is equal to 0, that means du by dx will be equal to 0. All right, that means in any of these graphs, wherever the slope is 0, f equals to 0 means du by dx is equal to 0. And what is du by dx? Du by dx is nothing but it is the slope in these curves or in these graphs. All right, so wherever you draw, let's say this will be a point of equilibrium, right? Because here the slope is equal to 0. This will be a point of equilibrium because here the force is equal to 0. All right, because why? Because the slope is equal to 0, nothing else. Just because the slope is equal to 0. All right, now let's go ahead and analyze this particular question out here. All right, chalo, let's move ahead to this. We will just take the function of the force from the previous one, that is fx is minus kx plus ax's cube. fx is minus kx plus ax's cube. So this is what we have as the function for force. All right, from this function I can easily find out what will be the function for my potential energy. How come? Very simple. See, try and understand. This will be force we know is minus du by dx, which implies that my du will be minus f into dx. A little bit of a integration that you have to do out here. So this implies that when you integrate it, you will get u as equal to minus integration of kx dx plus integration of a, this is x cube by the way, alright, ax cube dx, alright. So when you do the integration, you will get kx square divided by 2 plus ax to the power 4 divided by 4. So this is what you get as the expression. Okay, students, let me tell you one thing very, very clearly, that these kind of questions, they require little bit of a thought. Okay, it's not that these are typical kind of questions. It's for these questions there is a set methodology, there is a set pattern. So this is the pattern that I am actually trying to tell you. It may not be that while you were studying your work power energy, many students I have observed, because what happens is, by the time you are actually solving questions, okay, you might be doing work energy theorem and those questions, okay, and then suddenly in your coaching institute they might have started off with collisions and center of mass, and this particular part generally comes towards the end of the topic of your work power energy, okay, towards the end of the chapter. So a lot of students, they skip this particular part. Okay, they don't tend to do or solve problems, which I have encountered with lot of my students, okay, but this has got a set procedure. Once you follow this procedure, okay, you can easily score that 4 marks. All right, now once we have this, now try and understand. I said to you, the second point that you need to understand is the analysis of graphs. You need to understand is what? The analysis of graphs. Okay. Now you have this function. You have this function out here. See this very carefully. What will be the value? The first point on analysis of graphs is you try to say or try to find out that what will be the value of the function at x equals to 0. Okay. That means what will be the value of u, that is potential energy, at x equals to 0. Now if you put x equals to 0, the value of u will also be equal to 0. Pretty simple. Okay. Now in these graphs, then try to eliminate that option which does not give u equals to 0 at x equals to 0. Simple enough. This option is gone. That is my option A, B. This was option C. So option C is actually ruled out, because at x equals to 0, the value of u is infinite. Do you understand? At x equals to 0, the value of u comes out to be infinity. But all the other three options, are giving me a same this thing, that this is 0 here, this is 0 here, and this is 0 here. Okay. Acha. By the way, can I make u as equal to 0? That means take the function and make it equal to 0 and find out the value of x wherever u is becoming equal to 0. Alright, make u equals to 0, you will see that you will get, this implies kx square by 2, kx square by 2 will be equal to how much? Ax to the power 4 by 4. Ax to the power 4 divided by 4. Okay, solve it. You will get x square as equal to 2k upon a, which implies x will be equal to root of 2k upon a plus minus. That means x is becoming equal to u is becoming equal to 0 at x equals to 0. U is also becoming equal to 0 at x equals to plus root over 2k by a, and also at minus 2k by a. Okay? That means the value of potential energy is becoming 0 at 3 different points. Now 3 different points I don't need to consider, because I am only looking at the positive x direction. Alright. So u is becoming 0 at x equals to 0 and at x equals to plus some value, that is root over 2k by a. Now here, yes, at 2 different points it is becoming 0. Here at two different points it is becoming 0. But is it becoming 0 at two different points? No. It is becoming 0 at this point, but here it is tending to infinity. Try and understand. Here it is becoming 0, but here it is tending to infinity. Smart way of looking at it. Option B will also not be the correct answer. So this is the part that we call it as the analysis of graphs. Alright. So first thing, what do? You put the value of x equals to 0 and then find out the value of potential energy. Then you put the entire function to be equal to 0 and see where all points the function will become equal to 0. Right? These are the two things that we have done. And after that, the third point, this is all mathematics, right? So the third point, remember what we need to do. We figured out that at x equals to plus root 2k upon a, the function is becoming 0. Now let's try to see what will be the value of the function or the sign of the function at a particular point lesser than x. So let me take a value, that is, let's say x is equals to root over k by a and not take root over 2k by a. Root over k by a is lesser than root over 2k by a, isn't it? Try and see that if this is the correct answer, the value of the potential energy will be negative, right? In this, at x equals to root over k by a, the value of potential energy will be positive, right, students? So see it for yourself. Put it into this particular function out here. Put it into this function. What will be the value of x square, k by a? So try and see what will be the value of this function. The value of this function will be equal to minus k divided by 2. X square will be k by a plus a by 4 into x to the power 4. That means k square by a square. If you solve it, you will get minus k square by 2a plus 1a will go. That will be k square by 4a. Observe, it will be a negative value. It is going to be a negative value. That means for a value which is slightly lesser than this value here, the function is acquiring what? A negative value. That means option A will be the correct answer. Alright. Students, yes, I can understand that this was a lengthy question. Right? But sometimes we do have to make. It is all the matter of your concepts. If you remember the concepts well, you can get your answers correctly. Chalo guys, so I thought that a similar question, like these kind of questions, they definitely require practice. Okay, so what I would suggest is, here I have presented to you a similar question. So whenever you get time, just pause your screen, take a snapshot of this particular screen, alright, and solve this question and figure out for yourself which will be the current or the correct graph. Okay, think about it. Okay, so accept it and do as best as possible in those sections. Now in this question, what we have? In this question, what do we have? There is a rod of mass m hinged at O. So this is the rod. This is the rod here and it is hinged at this particular point. Okay, what do we see? It is kept in equilibrium with a spring of stiffness K. So this has got a spring constant K, right? What will be the potential energy stored in the spring? Alright, when is it that they are talking about? Potential energy will be stored not at this position. At this position of the rod, the spring is basically at its natural length. The spring is at its natural length. See, try and understand. This is the spring. See, this is at its natural length. Will there be any potential energy right now? No, there is not going to be any potential energy right now. But let's say I stretch it. Then potential energy is going to come. Now, if this is getting stretched, what is happening to the rod out here? The rod is rotating about the hinged end. Do you get that? Okay, so at some point in future, this rod is going to come at this point and the spring is going to be stretched. the rod is going to rotate, let's say by theta, okay, and this is going to come here, and then there is going to be a kind of extension in the spring. Let's say this extension is equal to x. Then the energy stored will be equals to half k into xs square. Energy stored will be equals to half k into xs square. Let's say it rotates by theta. Let's say it rotates by theta, right? Then can I say that this end has moved down by L into theta? Stretched. The spring is getting stretched. There is going to be a spring force developed. The spring force will be opposite to the direction of displacement. The spring has moved down, so the spring force will be acting in the upward direction. Fs will be in the upward direction. Okay. Here at this particular point, at the center, mg is going to act in the downward direction. Mg is going to act where? In the downward direction. So this force Fs and mg, they are going to produce clockwise and anti-clockwise torque. That's the reason the rod is going to come here and stop, isn't it? The rod is going to come here and stop. So I can say that my mg into L by 2 can be written as equal to Fs into L, because Fs is acting about this hinged point, the torque is equals to Fs into L, and about this point it is mg into L by 2, and they are producing torques in opposite directions, right? So we will get mgl by 2 as equal to kx into L. Simply L and L is going to cancel away, which implies the value of x will be equals to mg divided by 2 times k. Mg divided by 2 times k. Now we need to find out what will be the value of the potential energy stored, right? So the potential energy will be equals to half k into x square. So that will be half into k into, what is the value of x? Mg by 2k. Square it up. M square g square by 4 times k square. So if you see k, 1k will go away, you will get m square g square divided by 8 times k. That is going to be your answer. M square g square divided by 8k. Option C will be the correct answer. Now students, most of the questions that we are going to be doing from here onwards, it seems to be like, kind of a little complicated. If you look at this question for the first time, acha, there is string, there is pulley, there are blocks, there is a spring, another block. So they are asking us, find the maximum distance covered by C. That is, this is A, this is B, and this is C. Okay. So what is the maximum distance covered by C? So we would start to imagine that this will go by some distance A. This entire system will again further move down by the same distance A. Okay, if this goes here by A, this entire system also goes down by A. Further C moves down by some x. So the maximum distance will be A plus x. So that will be a lot of a lengthy procedure. But generally this question, if you look at, okay, the first thing is to analyze. The first thing is to analyze is whether this block A will even move at all or not. This block A will be at rest or will it be moving? If it is at rest, then JEE mains. If it is moving, then it is JEE advanced. Okay, so chalo, let's we are looking for boosting up our scores for JEE mains. Okay, so that's the reason why one thing is for sure, that it is not going to be moving out here. Alright, but still, if you look at this question, go deep into it and try to see if it is moving or not. By the way, I will tell you that you do it in both the methods. Okay, by how? I'll teach you. In the figure shown, masses of the blocks A, B, C are 6 kg, 2 kg and 1 kg. Okay, so this is 6 kg, this is 2 kg and this is your 1 kg. Simple understanding. 6 kg, 2 kg, 1 kg. ठीक है. अच्छा, अब देखो, mass of the spring is negligibly small. Mass of the spring is negligibly small, and its stiffness is how much? 1000 Newton per meter. This is pretty much fine. I mean, these are all the into 10. So this will give me, how much is the value? 8, 6, 8 are 48 Newton. Okay. This is the value of maximum friction, right? Acha, by the way, what is the force? This is the frictional force. But what is the force that is acting in this direction? Tension. Because of the tension, there is a tendency, there may be a tendency for this block to move in this direction, but friction will stop it. Right, friction is going to stop it. So I need to find out what should be the maximum value of this tension. Now this will come from where? If I take this entire B plus C as one unit, that is as a system, right? Then 2 kg plus 1 kg, let's say it is at rest. Let's assume it is at rest. Okay, so the maximum value of tension will be equal to how much? 2 plus 1, 3. 3 into 10. That will be equals to 30 Newton. That means T max, as I can see here, is 30 Newton. Now 30 Newton is acting in this direction, and maximum value of friction is how much? 48. So T is actually less than the maximum value of friction, as a result of which this block A is not going to move at all. If the block A is not moving at all, then finding out the maximum distance moved by C is not going to be very, very difficult. So what will be the maximum distance? It is nothing but we can simply imagine a block C which is connected to a fixed support by a spring. So the maximum distance is how much? You can find out half k x square, half m, sorry, let me just rub this off. Eraser. How will you find out the maximum distance? You can just equate the energy equation. It goes down by a distance x, potential energy will decrease by mgx, and your spring potential energy will increase by half k x square. Cut. So your x will be equal to 2 mg upon k. So this is your answer. You put down the values. Here of m is equal to 1 kg. So let me see here. It will become x will be equal to 2 into 1 into 10 divided by 1000. So 0.02, option B will be the correct answer. All right, students. So these are some of the questions that we have for our today's work power energy. And students, if you are liking and learning and enjoying, do not forget to press on the like, share, subscribe. Press on the like button right away, and actually share it as much as possible, because if these are the concepts coming to you guys as free, why not spread it as much as possible, so anyone at different corners of this particular country can actually have an access to these particular questions. Okay, now students, let's come to this question. I know today's session is getting to be a little lengthy, but because of the very fact that we have such interesting questions, which are I would say can be solved with only if you have a strong concept. And if these concepts are not revised at the final moment, then definitely it will end up that you know these things, you were having these concepts, you must have studied these concepts in your 11th standard, but a lot of times that's what exactly happens, because in your preparation of your 12th standard, we have been so much engrossed into the boards and the 12th standard that we have neglected the 11th. Before you have kept it here, then let's try to look at this block B first. Okay, see, try and understand what is the question they have asked is, when block B leaves contact with the ground, what will be the velocity of block A? Alright, so let us understand the mechanics behind the question. Okay. First you had kept this. At that time, what are the forces acting on block B? See, block B, tension force was here. 2G, that is the gravitational force was acting in the downward direction, plus normal force was acting in this direction. Okay, these were the forces which was acting on the second block. Okay, now block B was in equilibrium. Block B was in equilibrium, so the net force acting on this block would be equal to 0, right? But what happened? Tension initially would have been equal to what? Nothing but equal to mass of block A into G, right? But then this block A started going down. Try and understand. The block A started going down. If block A started going down, then what is going to happen? Spring force will increase. Spring force increases, all right, tension increases. Tension increases, there will be a time when tension will be more than 2G plus whatever the value that we have here. Okay, so tension plus normal will be greater than your 2G. But as soon as it leaves contact with the ground, okay, tension plus normal will be greater than 2G, but as soon as it leaves contact with the ground, normal force will become equal to what? 0. The normal force will be equal to 0 once this block leaves contact with the ground. Then what will be the value of tension at that instant? What will be the value of tension at that instant? Tension will be equal to 2G. All right, tension will be equal to 2G. Now just as soon as the block leaves the ground, the spring force will also be equal to tension, because this force and this force on the two sides of an ideal pulley is going to be the same. So if this is tension and this is the spring force, this is also tension. But this side, what do we have here? This spring is also massless. So spring force and the tension, they are actually balancing each other, right? So here the spring force will also be equal to the tension, right? Is this clear to everyone? All right. Now, what do we do here? Simple understanding. See, Fs will be equals to Kx. Fs will be equals to Kx. By the way, the value of K is given to me. So, from this, Kx will be equal to how much? 2 into 10. From this data here, 40 into x is equal to 20. So x will be equal to 20 divided by 40. So that will be equal to 1 divided by 2 meters. Okay, the value of the extension will be 0.5 meters. Clear? Now what do we need to do? Put down the value of x here. You will get what? You will get the value of change in kinetic energy. So let me go ahead and do it. Minus 5 into 10 into x. X is equal to how much? 1 divided by 2. 1 divided by 2 plus half into k. K, what is the value of k? It is equal to 40 into x square. X square will be equal to 1 divided by 4 will be equal to half into mass. Mass is equal to 5 into v square. So if you notice it, it will become 2 5 times, 4 10 times, 2 5 times. All right, so overall this will be minus 25 plus 5 is equal to 5 divided by 2 into v square. So this will be minus gx. So there is going to be something out here. By the way, students, the correct answer comes to 2 root 2. All right, so you just need to take a look at the solving out here. There might have been some mistake, okay, but this is the basic concept behind this question. All right, that is whatever is the loss in the potential energy plus that will be the gain in the spring potential energy will be equal to the change in the kinetic energy. So fine students, that's all the questions that we have for today's session. Now let's kind of move ahead. We had a few more questions, but we are running short of time. By the way, few important things that we have to give across to you students, that is the Instagram channel, right? So definitely remember that we have this Instagram page at @Unacademy JEE official. Go ahead and subscribe to this particular page, and you will be updated with whatever the latest happenings at Unacademy. Second thing is, we would want to be constantly in touch with each other. Now for that we have the app Telegram. So download the app and go to tinyurl.com/JEE live chat, and there you will be able to send us infinite number of messages about what you are feeling at the last moment of these examinations and what is exactly on your mind. How do you want us to help you students? Okay, another thing that what we have already discussed in the beginning of today's session, that is at this particular site, that is tinyurl.com/JEE mobile, you will get the entire video archive of all the lectures that has happened in the previous year. Okay, moving ahead, the Unacademy subscription, which is a very essential point. If you have not got the subscription so far as yet, now is the time, students, to go ahead with the subscription. Now what is it that you need to do, or what are the key features of the subscription? Is you get to have live sessions, you get to talk with the educators, interact with the educators, get your doubts clarified, let them know what are your pain areas, and in the process also be motivated by the educators. It is not just one side, it is dual side, right? So if you look at the dual side of it, then definitely we have the educators also trying to motivate you, build up your energy level before the examinations to a great extent. Okay, so that is very important. We have the live polls and the leaderboard. Okay, see the live polls, what do they do? The live polls, they simply increase the interaction in the class. All right, so this is kind of really very important. Achha, the test series and the analysis, that no doubt is going to be of very useful thing for all of you students, because you need to be into this process of completely writing tests, and not just writing the test and getting to know your marks, but rather the analysis of these tests are super important. Okay, acha, live doubt clearing sessions. All you need to do is click the photograph, post it, and your answers or your questions will get instantly resolved. Okay, see, one platform, many educators, and that's what Unacademy has done. You don't need to be like, you know, be very limited to one teacher, one educator. You have an access to a plethora of the best teachers in the country. One subscription, remember that. Okay, students, importantly, I don't need to teach a lot of things to the new age students. Unacademy learning app, install. Once the installation has taken place, go on to select plus, move to IIT JEE, and then use the code SMLIVE. Get right away 10% discount. So instead of 32,400, you have to only pay 27,000. Okay, and students, importantly, those who are watching this for the first time, do not forget to subscribe and press on the bell icon. Once you press on the bell icon, you will be constantly notified about the important sessions of different lectures which are happening on YouTube, and at the end of it you are also going to get the PDF notes in English. Okay, and students, besides the JEE English channel, we also have other channels where you can which you can recommend to people, those whom you know. That is, we have the NEET channel, the JEE, the foundation, and all that. Okay, and finally, students, do not forget the code SMLIVE. Use it as a referral code and get your 10% discount. Thank you, students. That's all from me for today. See you and God bless you.